Hello everyone. This is a demonstrator to present blockchain solution for the collaborative development of the digital reference. In this video, we will present one demonstrator of the whole work from the work package 5 about the evaluation of the industrial platform. We will talk about installing trust in semantic web models and how distributed ledger technology can help in this. Also, we will talk about establishing an automatic updated process system look like. Here you will learn as follows. What is digital reference actually? The digital reference was developed in EU-funded H2020/EXO Lighthouse Project Productive 40 with 100+ companies. The digital reference is an ontology that a semantic representation of the domain of semiconductors and corresponding supply chains. It is developed and maintained during the course of the funded project SC3. Trust in the semantic web is a core topic. It is designed to support the data integration from multiple sources and will be used only when people have trust in it. Having trust between partners who are developing an ontology is important. The current process to install this trust is challenging. The first challenge is that there is no integrated system to maintain the digital reference that enables collaborative development. The second challenge is that, to ensure the quality of the updated digital reference, currently, experts validate a new digital reference version by holding online or offline meetings, with the files delivered via email. This approach is sometimes inefficient. So all in all, let's look into how the blockchain solution helps overcoming the mentioned challenges. We present two approaches. The first one is email-based update process. In this solution we communicate requests for changes, which are communicated between stakeholders via email. Afterwards, the modification is implemented by a gatekeeper, that is, someone is responsible for the update of the ontology. Once the digital reference is updated, we create a new hash of the ontology and send it around to all stakeholders. With this solution is time-consuming and prone to human error. This is why we propose the following solution that relies on an automated approach using distributed ledger technology to install trust and allow updates for the ontology. What is distributed ledger technology? A distributed ledger is a database that is spread across several devices. Here means nodes. Each node replicates and saves an identical copy of the ledger. Each participant node of the network updates itself independently. When the ledger needs to be updated, a consensus algorithm will be applied to conduct the result, and thus nodes reach consensus on the updated ledger. You may confront with a question: how does blockchain bring trust? To answer this, you need to know its properties. First, decentralization. No central authority is required to be trusted not to tamper with the ledger. Second, distributed. The ledger on the network is maintained by all other nodes in the network. Third, immutability. Once the transactions are included in a block, it cannot be modified. Fourth, encryption. Encryption protects the sensitive information from getting into the wrong hands and being misused or forged. Blockchains generally use the SHA-256 hashing algorithm, as their hash function prevents. Fifth, transparency. A public blockchain is supposed to be a transparency machine in which anyone can join the network and, as a result, view all information on that network. Having those in mind, here is a good demo to see how does the architecture and prototype of the system look like. Here is the overview for the platform. Differing from the first clip, here you have a platform where you can collaborate with your team on developing the digital reference. Navigate yourself to our platform. Here is the prototype. Create your own account. Log in as the member 1. Put your user ID and password, and then click on the Submit button. Hover your mouse over the dashboard on your left-hand side. Click on it, and you will see your digital reference. At the button bar, click on the ontology, and then enter the ontology URI. And then you are retrieving ontology from File, Digital Reference in File. So you can create a new proposal by clicking on it on the left-hand side. Turn on your knowledge domain by choosing the power. Below put your URI. And then make the comment in the messages bar. And submit it. Now your proposal is created successfully. To encourage the interactivity in this platform, the member was charged 20 tokens for making the proposal. Another situation you might encounter, since member 1 is not a low boner, so the veto proposal cannot be created here. In addition, when clicking on the vote for proposal, and then accept it with your messages below, this action will also be rejected. In the meantime, the member 1 proposal is ongoing. The related version of the digital reference is allowed to be edited. Another role goes to your account. Being a low boner, member 2 can create a veto proposal and make the comment below. Here, you might be curious about what does the low boner mean? A low boner is a domain expert who has the qualification and the knowledge to approve and disapprove the update in the ontology. In addition, member 2 can vote for proposal 1 with 20 tokens charged. Here what happens to member 1. Member 1 will receive 20 tokens, for the proposal 1 was accepted. Lastly, for the new proposal 2, member 1 voted as a normal expert. It is member 3's turn to vote for proposal 2 as a normal expert, which is a so-called participant. Now log in as member 3. Give your user ID and password. And 2/3 of members have voted. Now the system is smart enough to close the proposal 2 as accepted. Now of course, member 1 will receive 10 tokens as reward of voting. In short, the version 2 will be the latest one. The update process has been completed. When the newest version is updated, and then the blockchain hash can be generated. In order to generate it, navigate yourself to your blockchain script and add reference to the latest version of the digital reference. Save the file and execute the program. And then new hash is generated automatically. In the prototype collaborative development platform, the function of the blockchain hashes storage is not implemented. That is why the hashes are currently being stored in the separated files. The blockchain solution will be fully integrated in the final version of the platform. Once a group decision-making process is improved in the supply chain manufacturing management for the semiconductor by means of the distributed ledger technology and ontology-based digital reference approach, the global supply chains management can be comprehensively integrated and communicated in an effective way. All in all, this video may be considered a promising aspect of that once a group discussion-making process is improved by means of the distributed ledger technology, the digital reference-based approach can be effectively applied for the global supply chain management. Thank you for your attention.